Welcome back, chemistry fans. Today, what we're going to do is the Unit 9 exam. We're going to do the multiple choice portion of the test to start. So let me share my screen and we will get started right away on these questions. Okay, so in this, we are asking ourselves what we know about these conversions here. So or how we know about the formulas. So in this problem, you are given a pressure. How do I know that it is a pressure? It's one of those weird units you've never heard of. And then these are my two volumes. So I can start with my V1 and I can start with my P1. Those are my two starting points. This will be my second starting point, what it has changed to. So what we're looking for is the final pressure. So I can plug in values 4.7, and 14 equals a pressure of unknown amount and a volume of 25. So we're just simply solving here for our new pressure. So 4.7 times 14 divided by 25 gives me 2.6. So that should have been your answer down here at the bottom. All right, moving on. Number 2, a gas solution mixture has equal amounts of A and B. Pure substance A has 8.8 moles. Pure substance B has 2.2. The total pressure of solution is 755. This is a partial pressure. It even states it here. So this is Raoult's law. So what we're going to do is multiply the partial pressure of B, and we're going to put on top we're going to do the mole fraction of B times the total pressure here. So this is just another little formula you should have had in your arsenal of weapons that you can do to solve these. It says that the total pressure is a sum of 8.8 and 2.2. That would be 11. So to get my mole fraction, I am going to put 11 on the bottom, and I'm going to put my mole fraction amount of B on top. I'm going to multiply this by 755. So 2.2 times 755 divided by 11, and you get 151. Okay, close that out, and we move on to question 3. Question 3 is asking us similarly questions about a formula. So density it's asking for. In this case, we've got D is equal to M over V. M is mass, V is volume. You've had this for close to probably 10 plus years of your life. It's probably time for you to know it by heart at this point. So we don't have a mass, however, so you're going to have to rely on your mole map knowledge, moles, to get it out to grams. So we're going to need to multiply by the weight of N2O. Each nitrogen weighs 14, each oxygen weighs 16, so that is 44. So that's my mass that's going to go on top. Now my volume I don't know. So what we're going to have to do to get that is we're going to have to do a PV equals nRT. I have the number of moles is 1. I have the volume is what we're looking for, but we do have a pressure of 1.53. Since it's in atmospheres, my R value becomes 0.0821. My temperature of 45.2 needs to be added to 273 to become 318.2. So what I'm going to do is divide both sides by 1.53 to get it by itself so that I have my V. So I've got 0.0821 times 318.2 divided by 1.53, and I get 17.1 as my V. Now that's not my answer, but that does belong up here now to get my density. So I've got 44 divided by 17.1, and I get 2.57, which is roughly that 2.58 right there, if we rounded it. Okay, number 4. We've got a barometer. It's sitting in a tub of mercury, and it says, what happens if we make the tub twice as large? The pressure is 760 on it, but what if we make the tub twice as large? What happens to the pressure? Well, nothing happens to the pressure. The air pressure stays the same at 760. Okay, number 5. Let's see, whoops, wrong way. So let's cancel that one out and we'll go to question number 5. Okay, so I've got a ratio that's given to me of P2 over P1, and they want to know what's the final pressure of this compared to the initial pressure. So they're wanting to know, what is this ratio? Well, all we have to do is then think about, we have in our arsenal an equation which is P1 over T1 equals P2 over T2. We would just need to rearrange this. So if we switch places with those, I would have I'm sorry, I got this wrong. Let me do it this way. If I switch places this away, what I would end up with is P2 over P1 equals, oh, and I'd have to, let's see, put that over here, and that goes over there. So T2 over T1. So that's all we're doing. We're doing final temperature over initial temperature, but we need to add 273 to both of these as always. So I've got 373 on bottom, 150 plus 273 gives me 423 divided by 373, and I get 1.13. So that's my answer over there, number 5. Number 6, molar mass. So I am given a volume, I am given a temperature, and I'm given a pressure. And you're saying, no, you're not. But STP, what you need to know, the temperature is 273 Kelvin, and the pressure would be 1 atmosphere. So it's asking for the molecular weight. Well, how do we do that? You're gonna have to think about the mole map again, because this time we are given grams. You multiply it by the molecular mass to get it to convert this. So first off, let's do PV equals nRT. Pressure, I've already stated, is 1. My volume is 2.1 liters. My number of moles, we don't know, because we're in grams of an unknown material. But we do know that we can solve for it, 0.0821, since we're in 1 atmosphere, my temperature is 273. All right, so let's solve this, get that N by itself. So 2.1 divided by 0.0821 divided by 273 gives me, number of moles is 0.0936. Moles times the molecular weight, the molar mass, is going to give me grams. So I got to get this all by itself. And that will give me the molar mass. 3.5 divided by 0.0936 gives me 37 roughly. That's the answer. All right, number 6 is done. Number 7 now. So let's jump into this. Number 7. A sample of O2 was found to effuse at a rate 2 times that of the unknown. So O2 is equal to a rate equal to masses over here, 32, and we don't know what the mass of this unknown is. But over here on the right side, it says that the oxygen is 2 times as fast as the other gas. So what we're going to do now is just simplify, and we're going to get rid of that radical. So we're going to square both sides. So I've got 4 is equal to x over 32. So to get the x by itself, we're just going to cross multiply 32 times 4, and you get 128. Number 9. Oops, number 8. What is the pressure in kilopascals if you have a volume here, a gram amount here, and a temperature here? So this is straightforward. PV equals nRT. Your pressure is what we're looking for. Your volume needs to be converted into liters. Your number of moles needs to be converted into grams, needs to be converted into moles. So I will divide by 44 the weight. So 2.34 divided by 44 gives me 0.053 moles. My temperature needs to be added 273 to turn it into a Kelvin temperature. That's 318.3. So now we just simply, we simplify. Oh, and sorry, my R value, because I am in kilopascals, is 101. We'll just go 101. All right, so now we simplify. 318.3 times 101 times 0.053 divided by 0.584, and we get 2,917. So this one is somehow not working for me. So I'm going to have to reevaluate my answers on this one. That should have been your answer right there, though, because I've got moles and I've got temperature and I've got an R value in kilopascals. My guess is I probably used ATM as when I was making the key for this one. All right, so we will have to figure out number 8, and we'll come back to that one in just a second. Number 9. Let me keep going on this one. Which is the order of slowest to fastest? The slowest are the big ones. The biggest one is the heaviest one. Here's 71. Here's 28. This is 38, and this is 32. So if we're putting these in order of slowest to fastest, we've got chlorine being the slowest. So right away, we can get rid of all the other answers. That's all you had to know, and you would have gotten your correct answer. All right, number 10, last of these. Which one of these is Boyle's law? Boyle is pressure versus volume. It is indirectly related. As one goes up, the other one goes down. That should have been this choice right here for Boyle's law. Okay, so hang tight for just a second. I'm going to go and fix that other question for us. So, okay, did you figure out what I did wrong? Because I did. I used the conversion. I didn't use 8.314. So whenever you use 8.314, you actually get the correct answer, which is 241. I'm so sorry, and I'm so stupid, and that was just a silly mistake. But thank you very much. Okay, this gets everything figured out for the multiple choice. Thank you so much for listening. I will talk with you again soon, and goodbye.